Inverse function theorem of derivatives. So let f and f prime, f and f inverse be the derivatives of each other. F inverse x derivative would be equal to 1 over f prime of f inverse x. Or we can say f inverse x derivative is 1 over f prime of y, because f inverse x is equal to y. F inverse x is same thing as y. In easy words, let's say f and g are the inverse functions of each other. To understand this, let's just try to simplify. Let's say a function f and a function g are inverses of each other. We know for inverse functions, their point switch, the x and y coordinate switch. If a point AB is on the function f, then the point BA is on the function g. If AB is on f, then BA is on g. So anytime you draw an inverse function, you might also think about, you can reflect it. So here you can also reflect your points along the line y is equal to x, and your x and y coordinate switch in that case. So remember, for inverse functions, the x and y coordinate switch, if the point AB is on the function f, the point BA is on function g. Using the inverse function theorem, g prime of b, which is the derivative at point B for the inverse function, is equal to 1 over f prime of a. So the corresponding point A and B is on f function, B and A are on g function. So g prime of B will be 1 over f prime of a. So we'll have to find the corresponding coordinate given to the coordinate we are looking at. So g prime of B will be 1 over f prime of a. G prime of A will be 1 over f prime of B. Or f prime of A would be 1 over g prime of B, or f prime of B is 1 over g prime of A. Let's see some examples. So suppose g of x is inverse of f of x, and we want to find g prime of 13. We're given f of x equals 3x to the 5th plus 6x to the 3rd plus 4. So we need to figure out g prime of 13. To find the g prime of 13, it's 1 over f prime of whatever is the number, the value corresponding to 13 on the f function, right? So that would be f inverse of 13. All right, so f inverse of 13, let's go ahead and find it. When the y value is 13, the x value at that point, 3x to the 5th plus 6x to the 3rd plus 4. 13, let's take everything to one side. 4 minus equal to 0. Let's go ahead and solve it. And I already have it on Desmos. I graphed this function on Desmos, and we can see it only crosses the x-axis at point 1. So x equals 1 is a solution for this equation. That means when y is for function f, the point x is 1, y is 13 on function f. And we can also say that point 13 comma 1 is on g. 13 comma 1 is on g. So the point 1 and 13 is on f. So that means g prime of 13 will be 1 over f prime of 1. 1 over f prime of 1. G prime of 13 would be 1 over f prime of 1. Okay, so let's go ahead and find the derivative f prime. F prime is going to be 15x to the 4th. F prime of x is 15x to the 4th plus 18x squared. So 15 times 1 to the 4th plus 18 times 1 squared, which is 1 over 33. Thus, we can say g prime of 13 is going to be 1 over 33. We could find the derivative of the inverse function without actually finding the inverse function. So what we need to do is we need to find the inverse of f of x, and then we need to find the corresponding point that has the y value of 13 for the function f of x. What is the x value for which the y value is 13 for the function f of x, and then find that would be g prime of b. So we just talked about the theorem here. G prime of b is 1 over f prime of a, and a and b and b and a are the coordinates on the graph of f and graph of g. Okay, let's see one more example. Given that f of x is equal to cos x plus 3x and f inverse of 3 pi over 2 is equal to pi over 2. We're also given this information. F inverse of 3 pi over 2 is equal to pi over 2. We need to find the derivative of f inverse 3 pi over 2. So using the theorem, now we're not calling f and g, we're calling them f of x and f inverse of x. So f inverse of x derivative is 1 over f prime of f inverse of x. Okay, so f inverse of 3 pi over 2 is 1 over f prime. What is the function, what is the x value for which, what is the x value for which the y value is 3 pi over 2? What is the x value for which the y value is 3 pi over 2? The x value is pi over 2. X value is pi over 2. So it's going to be f prime of pi over 2. So 1 over, let's go ahead and find the derivative for the function f really quick, and then we can, now we know f prime of x is, derivative of cos x is negative sine x plus a 3, because derivative of 3x is 1. So f prime of 3 pi over 2 is equal to 1 over f prime of pi over 2. Turns out to be 1 over negative sine pi over 2 plus 1, which is 1 over negative plus 3. Negative 1 plus 3, that's 1/2. So the derivative for inverse function at 3 pi over 2 turns out to be 1/2.